It's been a good day. So we've saved the best for last. Got some exciting stuff to show you here. So out of curiosity, are most of you only here for one day of the conference, or are you coming back for tomorrow, one day? Most of you are one day. Interesting. I like the way they've done this. So today is .NET Day, and I think tomorrow's like a Web and Mobility Day, then Java Day. Great way to organize a conference. I know some conference organizers in the U.S. that could learn from this. So, well, good. I'm glad we packed in as much as we can. My name is Jeff Procyse, and I'm going to be speaking for the next hour or so about building contracts in Windows Store apps. What it really means is building Windows Store apps that integrate with the Charms bar that slides out from the right-hand side of the screen on a Windows 8 device. On a tablet, for example, you can do sharing, you can do search, you can do settings, you can do devices through the Charms bar. To build a great Windows app, Windows Store app, you need to know how to integrate with that Charms bar, and that's what this session is all about, okay? So, if you've never seen the Charms bar before, it's what slides out from the right-hand side of a touch device running Windows 8. If you have a Surface tablet or something, for example, you can press Windows key C, or you can slide a finger in from the right edge of the screen, and you'll see the Charms bar containing the charms. Now, Microsoft has backed off on this just a little bit in Windows 8.1, and I'll say more about that in a few moments. But Microsoft's original intent was, this is how we're going to make it plain and obvious to every user of a Windows 8 device how they do things like initiate a search. You know, in the past, a lot of apps have used shortcuts like Control F for find to initiate a search. Some use Control S. There was no standard way. In Windows 8, at least, if a user could remember, hey, I can slide this thing out and tap this, and I can search from anywhere in any app. That was Microsoft's motivation behind building the charms in there. Now, when you build a Windows 8 app, you're never required to integrate with these charms. But if you want to be a first-class citizen in the Windows 8 environment, you will want to integrate with those charms. So the very first contract that we're going to talk about, contracts are what enable you to integrate with these charms, is the share contract. So in the old days with Windows, we had the clipboard, right? And we often shared data between applications by copying it to the clipboard and then pasting it from the clipboard into another app. While the clipboard is still there in Windows 8 and Windows 8.1, that is not the way Windows Store apps are encouraged to share data. Instead, they are supposed to implement share contracts. That means integrating with the share charm in the Charms bar. If you've ever done this, if you're running, maybe you're running Paint or something, you have an image, a bitmap in there, and you want to put that in an email, you can slide the Charms bar out from the right-hand side of the screen, tap Share, and Windows will then show you a list of all Windows Store apps installed on that device that know how to consume the type of data being offered, in this case a bitmap image. You tap one of those apps, it gets started up, the data is transmitted to it so that it can then, if the recipient app is the mail app, for example, that image can then be sent as an attachment in that email. So it is through share contracts that will let us integrate with the share charm that we have our primary mechanism for sharing data between Windows apps. Now, let's talk about details. Let's say you're writing a Windows Store app, and you want to be able to share data from it to other Windows Store apps. What you need to do is implement the share contract. That means that when the app starts up, or perhaps in each of its pages if it's a multi-page app, you need to register a handler for data requested events fired from a class named Data Transfer Manager. Now, in Windows 8 and in Windows Phone 8.1, by the way, this API is there. Data Transfer Manager.getForCurrentView returns a reference to an instance of Data Transfer Manager. It fires the data requested event. Here's what happens. Now, if while your app is running, the user slides out the Charms bar and taps the share charm. That was probably me getting too close to that speaker. If the user slides out the Charms bar with your app running and taps the share charm, then Data Transfer Manager will fire a data requested event. You respond to that event by providing to the system via the Data Transfer Manager whatever data you want to be able to share with another application. Now, inside that event handler, through e.request.data, e being the event args passed in, you get a reference to a data package object. It is that object that has the API, that has the methods that you call to actually share the data with Windows so that it can in turn share it with other applications. This is the list of methods that you can call on a data package object inside that data transfer requested or data requested event handler in order to share data out. Now, if you've ever done clipboard programming in Win32, you'll recognize a familiar pattern. For years, when we use Windows Clipboard API, we can put the same data in multiple formats on the clipboard. We could share a text version, a bitmap version, an RTF version, and others. The same concept was borrowed here. You can, if for example, you're a word processor or a simple text editor or code editor, you might only want to share text. So when that data requested event fires, you call set text on the data package object and specify the text you're willing to share. But you can also share the same data in other formats as well. In other words, you can call as many of these methods as you want on the data package object inside a single data requested event handler to try to make this data as portable and consumable as possible by apps that consume the data. So here's an example. Suppose from my Windows Store application, I want to share out a simple string of text. So I register a handler for data requested events. When that event fires, on the data package object that's handed to me, I call the set text method. Now the operating system will respond by showing me, the user, a list of all the Windows Store apps installed on this device that have indicated through their manifest that they can consume text. On the other hand, if I wanted to do something a little bit richer, if I wanted to share an image rather than simple text, then instead of calling datapackage.setText, I would call datapackage.setBitmap. Now, there's a little bit more involved here than sharing simple text. You notice I'm doing this thing in WinRT, random access stream reference, create from URI. I'm actually wrapping a random access stream object around the image that I want to share so I can pass a reference to that random access stream to datapackage.setBitmap. It's a little bit complicated, but it works. But I'm going to show you an example of this in a moment that's actually a lot more real world. There are samples like this in MSDN, but when it comes to really sharing images through these contracts, there are very few samples in the world that show how it's really done. There's typically quite a lot of code involved. I'm going to show you that sample here in just a moment. Before I do that, let me mention something here that may be the most important thing you ever learn about Windows 8. And by the way, the same applies to Windows Phone 8.1. Deferrals. When Microsoft designed WinRT, the new Windows runtime, the new Windows API, they designed the API to be highly asynchronous. Why did they design it to be highly asynchronous? Because in the past, it has been all too easy to write really bad code by doing synchronous I.O. You never, ever want to do synchronous I.O. on an application's UI thread because you block the message pump, the app becomes unresponsive. If that's a call you've made over the internet, since you have no guarantee how long it's going to stay out there before it comes back, you never want to do that synchronously. That's why in WinRT, whenever we call a method that does I.O. of any type, whether it's file I.O., network I.O., or whatever, WinRT only gives us an asynchronous version of the method. They literally don't even give us a synchronous version. That's really good. But here's the deal. Here's a data requested event handler. You've written this because you want to be able to share data out from a Windows Store app or a Windows Phone app that you're writing. When it's called, the system attaches special meaning to the return value. When you return from this event handler, the system assumes you've shared via calls to data package methods whatever it is you wanted to share. But here's the problem. Very often when we code up these data requested event handlers, we call WinRT methods that are asynchronous. They do asynchronous I.O. to the file system or to the network, for example. If you use C#5's new Async Keyword, which is brilliant, by the way, one of the smartest things Microsoft has ever done was the Async Keyword. It makes it almost as easy to write highly asynchronous code as it is to write synchronous code. Do you know what the async keyword really tells the C# compiler to do? It tells it to emit IL that returns from the current method and calls back into it after an asynchronous I/O operation has completed. Well, think about that. If you use C# async keyword inside a data requested event handler, the async is actually making the method return, even though you don't see it in your code, it's only in the IL. At the moment the method returns, Windows assumes you've shared out everything you need to. So all of a sudden, nothing gets shared out, because Windows ignores then what you try to share out when you return into the method for the second time. The way you fix that in WinRT is with the deferral. There are 5 or 6 instances in WinRT in which it is critical to use deferrals. This is one of them. If in the body of this data requested event handler, I'm going to do async IO by calling an async WinRT method, that is, I'm going to use C# async keyword, I must first call get deferral on the data request object made available to me through the event args. You know what that really tells WinRT? It tells WinRT, hey, I'm going to return from this method, but don't assume that I'm finished. I've got more to do. In fact, when I call get deferral, the system will not consider that I'm done sharing everything out until I later call the complete method on that deferral object. You see what this does? Now, I can do as much async IO in here as I want. I can use the C# async keyword as much as I want. I can return from the method, re-enter it, return again, re-enter it, and Windows doesn't care because I requested a deferral. Again, this is not the only case in WinRT where this is necessary, but when you need a deferral, you need that deferral badly. You'll see an example of this in my next code sample. By the way, let me ask you this. What if in your data requested event handler, something goes wrong? Maybe an exception is thrown that you can't recover from, or you attempt some I/O that fails. You could pop up a message dialog letting the user know that it failed, but there's a better way to do it. You can use the fail with display text method on the data request object to pass an error message to Windows, which it will display in the system sharing pane. That way, the error messages displayed by your app when it's attempting to share are consistent or presented consistently with respect to messages presented by the built-in Windows apps. One other thing you can do, too, yeah, that's a good idea. There's way too much noise out there. Can we close the door, please? Yeah, there we go. Awesome. Oh, much better. Sounds like they're having a party out there. We should be part of the party, right? Actually, what they don't know is that we're having the party in here because we're learning how to do sharing in Windows Store apps. So another thing you can do with this API that can be useful, you can call a static method in the data transfer manager class named showShareUI. All this does is it programmatically pulls out the system sharing pane. In other words, it does the same thing that would have happened if a user had slid the charms bar out and tapped the share charm. Sometimes it's useful to be able to present that UI to the user programmatically, especially in Windows Phone. So they give us a very simple way to do that. Now, let's take a look at some sample code to see share sourcing at work. I'm purposely, for lack of time, not talking about how to write what Windows calls a share target, how to consume the data. I do want to show you how to source the data, how to share data from your Windows Store app with other apps. So let's go over into Visual Studio here. And at the end of the session, I'm going to give you a URL where you can download this sample and a whole lot of other samples showing how to do things in Windows 8 and 8.1 that I won't even cover in this class. But I'm going to go open this sample here. Go from my samples folder to Windows 8.1, and the one I'm looking for here is, which one did I put it under? Contract demos, there we are. So this is about the simplest possible sharing example. I built this just to show how simple it can be. Here's what it does. When we run it, this is a Windows Store app that shows the text of the Gettysburg Address. Now, in India, you may not know what the Gettysburg Address is. It is one of the most famous speeches in American history. It was given by President Abraham Lincoln. And it's a famous speech in part because it is so short, and yet it's very profound. So every school child in the United States has to learn the Gettysburg Address. We all hated it but we came to appreciate it later in life. All this app does is show the text of the Gettysburg Address. But watch this. I'm good on this touchscreen. I'm going to slide out the charms bar, do a share. And under the hood here, what I've done is I've taken the data requested event and I've called set text to offer to share out to any app that wants to consume it the text of the Gettysburg Address. Now, Windows has checked the manifest of all of the apps that are installed on this device, and it has found that there are 4 that have indicated through their manifest that they are capable of consuming text shared by other apps. They are shown right here. There's one SDK sample that I use. It's great for testing because it will receive almost any kind of data. Then there are built-in apps like the Mail app. What I'm going to do is tap that Share Target C# sample. Again, this is from the Windows 8 and 8.1 SDK. It's a great little diagnostic and debugging tool because it shows me exactly what is being shared out from this app, and I can see that it is indeed the Gettysburg Address. Now, in an app as simple as this one, it's easy to do this sharing. Let me show you what I mean. We'll pop right back over to Visual Studio. And if you look at the code here, when this app starts up, right down here, I register a handler for data requested events. Remember, that's the event that fires if my app is the active one when the user taps the share charm. I'm using a lambda for the event handler to keep it simple. When the system says, okay, what do you want to share? I provide a title which is required, a description which is optional. Then I call datapackage.setText just to share out the entire Gettysburg Address as one big string. And that's really all there is to it in this simple example. But let me show you what it looks like in the real world and what you don't find samples for on MSDN. I'm going to open a completely different project, but one that also does sharing similar to this one. So let's go into my Contoso folder, and I'm going to run an app, a Windows Store app named Contoso Photo. Here's what it looks like when it runs. It will start off by showing me a message that says tap here, so I'll tap here. I display a Windows file open picker, allowing the user to choose an image file, and I'm going to choose this picture of my daughter right here, and I'm going to zoom in so you can see it now. It's an old picture. She's 20 years old now, but I think you can see. Can you see how red the eyes are in that picture? The reason I'm using this here is because of all the pictures I ever took of my kids, this one probably had the reddest eyes, but watch this. I'm going to tap those red eyes, and I'm going to fix them. So I'm taking the tap events that are firing from WinRT, and I'm running a red eye reduction algorithm on the pixel under the cursor and in a neighborhood around it. It's a pretty simple algorithm, by the way. It's effective in localized areas. You just compare for each pixel in that area the value of the red component of the pixel to the sum of the green and blue. And if the value of the red component of the pixel is higher than the sum of the green and the blue, then you set the value of the red component equal to the average of the green and blue. It's an incredibly simple yet effective red eye reduction algorithm run in localized scenarios like this. Now, here's the cool thing. Let's do this. Let's zoom back out so you can see it. I'm going to share this thing. So I drag up the charms bar, tap share, and once more the system is showing me all the apps installed on this particular device that have indicated through their manifest that they're not only capable of receiving shared data, but they will receive bitmaps, which is exactly what I'm sharing out right here. So once more, I'm going to select the Share Target C# sample out of the Windows SDK because it's one of the few apps that makes it really easy for me to make sure that what I'm sharing out is what I intend to share out. It's a little hard to see, but did you see there are no red eyes in this picture I'm sharing out? I'm sharing out a live bitmap. Most of the examples in MSDN that show how to show images are not very useful in the real world because what they have you do is go out and simply load some little in-package image that you've built into your project and share it out. It takes 3 or 4 lines of code to do it. Here, where you're loading an image that the user has selected, you're wrapping a writable bitmap around it so you can not only read but write the individual pixels. When you want to share that edited bitmap out, it is much, much more involved. And guess what? One of the things you're going to need is those deferrals we talked about. Let me show you what the data requested event handler looks like here. So, to scroll up to the top, in fact, let's just do a quick search on data requested. There we are. See, can I do a view code right there? We'll just go a little further down. Let's search for the next instance. And there we are. Here's the data requested event handler. Let me show you what's going on here. So when the user taps the share charm with my app as the active app, and therefore this event fires, the first thing I do is I make sure that I've loaded a bitmap, that the user has loaded a bitmap, because if they haven't, I have nothing to share out. If they have loaded a bitmap, then I'm going to do some work down here to share the image out. And one thing you see here is me using C#'s async and await keywords. That means I'm going to need a deferral here, because remember, when the compiler sees this await keyword, it's generating code that actually returns from this method. And by default, Windows is going to think you're done sharing, but you haven't even got a chance to call setBitmap yet. So I ask for a deferral. I do all the work I want to do, including async work, and then I call complete on the deferral, letting the operating system know that everything I intend to share out, I have shared out, so it can now present that share target UI to the user. What do I do in between there? The challenge is to take that bitmap, whose pixels I've edited, and to write it out into an in-memory stream that can be handed over to Windows. Now, the stream data types in .NET and WinRT are different. They do not match one-to-one. So in WinRT, what I actually need is not a memory stream from .NET, but what WinRT calls an in-memory random access stream. So basically, I'm creating an in-memory random access stream, and I'm calling an async helper method I wrote named encode bitmap to string async. This is where I actually do the work, calling into WinRT to take all of these raw image bits, this raw bitmap, and JPEG encode all the pixels. The good news is I didn't have to do a lot of that myself, because WinRT has great support API-wise for encoding and decoding images built into it in all the popular formats like JPEG and PNG. So I'm calling that method there. Ultimately, I pass that in-memory random access stream over to WinRT via this call to set bitmap, and boom, you've seen now that I can share out that live image. If you ever have a need to share out live image data, something more like this than the simple, almost trivial examples they show you in the SDK, here's a good example to draw from. Take the time to dig through this method right here in the helper methods it relies on, and that'll help you get this thing to market a little bit faster. So that's sharing. Any questions about sharing? What does it do? It allows us to share data with other Windows Store apps. What does it look like mechanically? Pretty simple. When your app starts up or when your page loads, you register a handler for Data Transfer Manager's data requested events. That event fires when the user taps the share charm. When that event fires, you call data package methods like setText, setBitmap, setHTML, or whatever to make the data you want to share available in as many different formats as you want to make it available. That is the big picture on sharing. Okay, let's talk search, because that's another contract. Now, I said earlier that Microsoft has backed off a little bit on their whole notion of using the charms bar and these contracts. And what I was specifically thinking about was search. In Windows 8, when Microsoft introduced Windows 8, they urged developers to use share contracts to integrate with the share charm in the charms bar. The idea, again, was that if you were a user, not a developer, you were using a Windows 8 device, using an app, and you wanted to do a search no matter what app you were running, if you can remember that all you have to do is tap the share charm in the charms bar to initiate a search, well, that's pretty easy. It's going to work the same in every app. Guess what? Between Windows and 8.8 and 8.1, Microsoft changed its mind just a little bit. Why? Because the public found the Windows 8 interface, the UI, a little bit more confusing than Microsoft anticipated. That's probably an understatement. Microsoft actually did a lot of research, usability studies, to see how people were using Windows 8, to see what parts of the UI they were adapting to very well, what parts they were having trouble with. And one thing they found was almost no users knew about the search charm. So no one was using it. So the guidance in Windows 8.1 changed. Microsoft said, forget about the search charm. They gave us a new control that in XAML is called the search box control. They said, let's make search easy. Put it on the start screen. If any of you have used Netflix's Windows 8 app, Netflix since day one has put a search box and a magnifying glass up in the upper right-hand corner so anyone who uses it can figure out immediately how to do a search. That is the pattern that you and I are supposed to use today. So, it's not really a contract anymore. We're not really integrating with the search charm in the charms bar. Instead, we're using the new search box control. So I'm going to show you an example or two of an app that uses this in just a moment. Again, we declare the control. We put it typically in the upper right corner of our page, although that's up to us. It looks like this. When the user types something into that control and taps the little magnifying glass out on the right-hand side or presses the enter key, the control fires an event named query submitted. So at the very least, when I declare an instance of this control, I want to wire up a handler for the query submitted event. In the handler, through the query text property of the event argument passed in, the system tells me what the user typed into that search box. It's then up to me to go do the search. Obviously, what I do from this point on is going to be very app-specific, very domain-specific, but at least I've been handed the text that the user wanted to search for. But there's more that the search box control will do. For example, it supports what we call query suggestions. Have you ever run a Windows 8 app where as you type something into a search box, a drop-down list appears, and it changes with each character you type to provide context-sensitive help, context-sensitive completion suggestions? The search box control builds that functionality in. If you want to support that, then when you declare a search box control, you designate a handler for suggestions requested events. And with each keystroke, each character that the user types into that search box control or deletes from it, this event will fire. Your job when it fires is to return essentially it. You're calling a method named append query suggestion or suggestions. You are telling the system what strings you want to appear in the drop-down list based on what the user has typed so far. Now, currently in Windows 8 and 8.1, it will never show more than 5 suggestions. You may add more than that if you want in anticipation of some future version displaying more than that. So totally up to you. By the way, there is one other feature that the search box control offers. It's lesser known, but I want to at least make you aware of it. It supports query suggestions and result suggestions. Now remember, query suggestions are strings that appear in a drop-down list that change with each character type. And you implement them by responding to the search box control suggestions requested event. Result suggestions also appear in the drop-down list, but they are accompanied by a little thumbnail image, an icon you specify. When the user selects a query suggestion from the drop-down list, the text of that query suggestion is copied into the search box control, but the search isn't actually initiated. If you elect to provide result suggestions, and the user selects one from the drop-down list, then not only does the text get copied into the search box control, but the search box control fires a query submitted event. So you're only supposed to display result suggestions if you are relatively certain, based on what the user has typed so far, that you know what they're ultimately going to type. Because if they select that result suggestion you display, it is going to initiate a search immediately. The truth is, not many Windows 8 apps use result suggestions. A lot of them use query suggestions, but not result suggestions. So let me show you here. There is result suggestions. Let's see search in action, Windows 8.1 style, okay? So I've got several samples of this. I'm going to show you a couple. And remember, in fact, help me remember, at the end of the session, I'll give you a URL to my OneDrive where you can download all these code samples and a lot more, okay? In fact, I'm going to do that right now so that I don't forget it. How about that? Because I can be very forgetful. My wife reminds me of that from time to time. Let's see, so out to OneDrive. Does anyone else have trouble calling it OneDrive? I still want to call it SkyDrive all the time. OneDrive just does not feel right, does it? Maybe at some future date it will, but right now it does not. So here is the URL. See Windows, where are we? Windows 8.1 samples here. Let me get you a link to it. And I'm going to paste that into Notepad. And there we are. Remember, these OneDrive URLs are case sensitive. But at your convenience, you can go here. It's a fairly large zip file. I think it's 45 or 50 megs. Contains lots and lots of Windows 8.1 code samples. This is from the course that we use to teach Windows 8 programming to Microsoft developers internally. So there's a lot of good stuff in here. And I'll bring this back up at the end of the session so that you have it. That's a 0, not an O. And remember, these OneDrive URLs are case sensitive, okay? And I'll pause for just a moment there. Give everyone a chance to get it down. All right, and now I'll bring it back up. You didn't get a chance to write it down. I'll bring it back up at the end. So, from those samples, let me begin by bringing this up. Project name, Contoso Cookbook. Now, I originally wrote this for Microsoft. They hired me to... One of the things I do for Microsoft, interesting, what am I getting? I bet I need to do a clean on the solution. One of the things I do for Microsoft is I do white papers, and I build samples for MSDN and stuff like that. And back before Windows 8 came out, Microsoft wanted sort of a reference application accompanied by several hundred pages of labs so developers could learn to write Windows Store apps by building one from start to finish. So I spent a few months of my life building this sample called Contoso Cookbook. I've since updated it for Windows 8.1. In the original Contoso Cookbook, I used the guidance that Microsoft was giving us at the time. I integrated with the search charm in the charms bar. In this one, which was updated for Windows 8.1, I no longer integrated with it. Look what I've done. Instead, I put a search box control right up here in the upper right-hand corner. So when you start this app, it's obvious how to do a search. So maybe we want to find out if there are any recipes that have sugar in them. Notice the suggestions, query suggestions that are coming down there. When I type in S, I show 2 of them. Let's just go down and select sugar directly. Now, here are the recipes that have sugar in them. If we select one of those, then we should see here where somewhere in here, there we are. There's where sugar appears right there. Click back. We can go all the way back to where we were. Now, this was pretty easy to do. In fact, let me show you one other, and then we'll dig into the code for it. So one of the things I've been doing a lot of work on recently is something called universal apps. How many of you have heard of those out of curiosity? Yeah, of course, because you're on the cutting edge. Microsoft only announced these at Build a few weeks ago, right? What is a universal app? It's an app that runs on Windows PCs, Windows tablets, Windows phones, and soon, Microsoft says, other devices such as Xbox Ones. So Microsoft is working very hard to get to a point where we will have one programming model for all of these different devices. And in fact, in Windows Phone 8.1, they've ported so much of WinRT into it, almost all code you write for Windows 8 will run unchanged in Windows Phone 8.1. It's very, very, very cool. Universal apps are a new project type that you can create once you've installed the RC release of Visual Studio 2013 Update 2. This next example I'm going to show you comes from a universal project. So let's see here. I'll do an open, and I've got a separate folder here called Universal Apps with several that I'm building. This one is called My Comics Reader Universal. And it is a Windows Store app and a Windows Phone app, for that matter. I'll run the Windows Store version. It goes out to Azure and pulls out information about my comic book collection, which I put out in the cloud there. Okay, interesting. So either Azure is slow or I've got a really slow connection. I should be able to, usually the second time's the charm. Let's try that again. I could also increase the timeout if I need be. I'm actually making an initial call out here. I'm getting back a fairly large JSON string describing about 1,800 comic books. And it looks like it's not going to... there we go. It's okay. I also built in a provision, so if it couldn't get the data, it would rely on local data, so it's just as good this way. So what you have here is all these comics. If you like Batman, for example, or Avengers, let's select Batman. I'll take you over to another page where I've got a custom control here working, a custom cover flow control, so I can just thumb through them. I tap one of the cover images like this, and I'll see it in large view. Looks like the bandwidth, because I'm using a shared connection, is a little slow. So you see a close-up of the comic, you tap it and it spins around so you can see the back. You can also side scroll using a flip view control between the various comics and stuff like that. So lots of cool stuff. I actually built this and published it after Contoso Cookbook because even with the 300 pages or so they gave me to write the Contoso Cookbook thing, the labs, the instructions, I still couldn't cover some of the more advanced things you needed to know to write Windows Store apps. So this one, this My Comics app, covers some of the more advanced scenarios that the Contoso Cookbook doesn't. But you may have noticed one of the things it does is it does feature search. Same thing again. I just put a search box control up here. And if I wanted to find out, Steve Ditko was one of my favorite comic book artists from the 1960s. If I type in his name, here are all the comics that were in my collection that are tagged with Ditko. So let's just select one of these. Let's just find one. Maybe, are there any that are really cool? This one, here's an old Strange Tales comic here. And there should be some others as well, but you get the idea. Right here, you can see why I found Ditko, because it's in this comment right here. So real quickly, just how did we do this? How do we implement the search? And again, Microsoft has divorced these in Windows 8.1 somewhat from the actual search charm. But if you look in, let's see here, hubpage.xaml, which is the home page in this Windows version of the app, you can see that I declare a search box control. I think I did that down near the bottom. Here it is. I've also wired up handlers, as you saw in the slides, for suggestions or requested events, so I can provide drop-down query suggestions, and for the query submitted events, which it fires once the user has finished typing a search term in and has clicked the or tapped the magnifying glass or pressed the enter key. So if you want to see what this looks like, there's not a lot to be learned here, but it is what's done in the search is very domain specific. What I'm doing here in the event handler is taking the text that the user typed, and I'm actually navigating over to another page, my search result page. There, I take what the user typed, and I do a search of all the comic book data, which I built in memory from what I pulled down from Azure. This is pretty typical. By the way, if you've never seen a Windows Phone app before, a Universal app, remember this exact same thing runs on Windows Phone. This solution contains a separate Windows Phone 8.1 project. If I make it the startup project, now it's going to launch in the Windows Phone emulator. All the logic used by the Windows Phone version of this app and the Windows version are exactly the same. Let's zoom that up just a little bit. Actually, I probably need to zoom it back down. It is only the UIs that are different. So I've skinned each one of them a little bit different in XAML, but I've let them both share all the same underlying logic. So here it is in the emulator. Here, if we go to Batman Comics here, you're going to see this cover flow control appear with all the Batman comics there. I tap one of these. It navigates over to a page that's going to show me a detail of the comic, and just like in the Windows version, it flips around. Again, 95% of all the code in here, in fact, more than that, more than 95% is exactly the same for the Windows app and the Windows Phone app. That code is actually sitting in a separate project called mycomicsreader.shared. All I had to do was skin this thing differently on for the different devices. I even published a blog entry recently showing how you can use the exact same XAML files and XAML code behind files for the Windows Phone app and the Windows app. But if you want to see the thing running on my phone here, well, actually, I've got networking turned off. I'm not connected to the network, so, and I don't have data turned on because it's expensive for an American traveling in India, so I can't do it that way. But I did build a universal version of Contoso Cookbook that does not require a connection. Here's Contoso Cookbook running on a Windows Phone. I can side scroll like that to see the different types of recipes. I can tap one of them to see a recipe detail. Again, all the code, every line of C# code is shared between the Windows Phone app and the Windows app. All I did was build separate XAML files to skin the app differently in each device. The future in Microsoft land, the future if you're a Windows developer, is universal apps. It's just getting better from here because in the future they're going to be supporting other devices as well. Okay? So anyway, implementing search today, pretty simple. Search box control, process some events, and you can build that search functionality into any Windows Store app or any Windows Phone app. Any questions about that? All right. Yes, sir. Yeah, how much time did it take me to port the old code to the Universal app? It took me about 15 minutes. Because I had written a Windows 8 version of this. All of that just worked in Windows 8.1. And every line of it worked without change in Windows Phone 8.1. So, in case you don't know, the big news in Windows Phone 8.1, in Windows 8, they began a convergence of APIs between, I should say in Windows Phone 8, they began converging APIs. Windows Phone 8 still have the old Silverlight for Windows Phone APIs, but they took about 20% of Windows WinRT and brought it over to Windows Phone. That means you could share a small amount of code between a Windows 8 app and a Windows Phone 8 app. What Microsoft has been working on really hard for the last couple of years is porting the remainder of WinRT over to Windows Phone 8.1. And I can only talk about this as of build a few weeks ago. Now, almost any code you write for Windows will run unchanged on a Windows Phone. There are a few exceptions. So with the Universal app, you're letting the same code drive both versions of the app, but you're using different XAML files on each platform to make the app look as good as you possibly can on each device. And it works amazingly, amazingly well. If you want to see some examples, if you want to read more, do a search on my blog. Do search on Procise blog. My last name is spelled P-R-O-S-I-S-E. It should be on the cover slide. The last 3 posts I've done have been about universal apps with downloadable samples like these right here, okay? But let's move beyond search. Another important contract to know about is the settings contract. Now, what's so important about the settings contract? Well, it's this right here. When the user slides this charms bar out, they can tap settings. And here, because I'm on the desktop, I see the system's settings pane. But when you build Windows Store apps, you can add commands to this pane which will appear when it is displayed with your app running. And then you can write handlers to display custom UIs when those commands are selected. I want to show you how to do that and then show you an example or two of apps that do it. So we call this implementing a settings contract. It is building a little bit of logic into your app to be able to respond when the user with your app running taps the settings charm that you see boxed in down there in orange. Now, this is a pretty simple contract to implement. Here's the way you start doing it. When your app starts up, we typically do this in app.xaml.cs, you register a handler for commands requested events fired from WinRT's settings pane class. This is the event that fires in your application if, while your application is running, the user slides out the charms bar and taps the settings charm. What the system is doing here is asking you, do you want to add some custom menu items or custom commands to the system's settings menu? If the answer is yes, then for each command you want to add, you new up a settings command object. You provide the text for that will represent that command in the settings pane, and you provide a reference to the method or the delegate wrapping the method that you want to be called if the user selects that command. So pretty simple stuff. Now, when the command is selected, when a command you've added in the settings pane is selected, what you typically want to do is display what's called a settings flyout. That's what's actually flying out from the right side of the screen when you tap the settings charm in the charms bar. That little the window that slides out is called a flyout. Well, here's the rub. In Windows 8, they implemented a flyout control in WinJS for JavaScript developers, but they did not get around to implementing one in XAML for C# developers. Fortunately, they fixed that in 8.1. They introduced several new controls in Windows 8.1. One of them is called the settings flyout control. In Visual Studio, you can do an add new item. It will derive a class from settings flyout for you, give you some starter XAML, makes it incredibly easy to build settings flyout UIs. Okay? I'll show you that in my next example here. Before I show you that example, one thing we should discuss is this. Where If you're going to expose settings through the system settings pane in your app, where do you store those settings? You want to store them in a place where they're going to be there. They're still going to be there the next time the app runs, right? So I want to give you a quick answer to that. If you're new to WinRT, one of the namespaces that you should spend some time exploring is one called windows.storage.apple or windows.storage. There's a class in it named application data that provides basically 5 different repositories for data that your applications might want to store. They have names. One is local folder. If you want to store data on the client side in a persistent way, but you don't want to roam the data, you don't want to share it between devices, you can store it in local folder or local settings. Local settings is basically a dictionary of key value pairs. Local folder is a folder reference into a sandboxed file system where you can store more complex data. Now, if you store the data in local folder or local settings, it's local to this device. But guess what? If you write it into roaming folder or roaming settings, it actually gets synchronized through the cloud to other devices running this app when the same user is logged in. So you could build a comic book reader, for example, and each time the user flips a page in it, you could write that into roaming settings. Then, when I go home from work, if I've been reading comic books all day at work, of course, that's frowned upon, I go home, I fire up the same application on a different device at home, and it automatically takes me right to where I'd left off reading that comic book at work. That is the value of roaming settings. So, this is where we store settings data that a user enters. If I want to use local settings, again, it's just a dictionary of key value pairs. Here I'm demonstrating how to write a simple language preference into it. And here I'm demonstrating how to read that language preference out. Now, since I'm using local settings here, it will be local to the device. But if I were to simply change that code to target roaming settings instead, this language preference would apply not only to this app on this device, but the same app on any other devices that is registered for this user. So application data, one of the more powerful parts of WinRT, one use for it, not the only use, but one use is storing the settings that the user enters through your settings UIs. So let's see here. Let's see settings at work. And one way to do this is to go back to that Contoso Cookbook app. In fact, I'm just going to open the universal version of it. How about that? Where I spiffed it up. I dressed it up just a little bit. Let's see here. Let's get her started. Let's see what this version looks like. This one I'm using, instead of a grid view control as I used in Windows 8, I'm using the new Windows 8.1 hub control. If we pick one of the recipes, I've changed the format just a little bit to make it look a little bit cleaner and more dressed up. But it's the same basic application. But look at this. If I go to the Charms bar and tap Settings, I've responded to the commands requested events fired by the system, and I've added 2 commands to the system settings menu. I've added an about command, which contains information about this application and who wrote it. And I've also added a preferences command where I let the user decide whether, when this app starts up, should it get its recipe data from an in-package resource that doesn't require an internet connection, or should it go out and talk to a service that I've stood up in Azure to get the data. One reason I built this in is so that if I'm doing this demo without an internet connection, it works anyway, right? But I decided to expose that through a setting. So here's a settings flyout with a Windows toggle switch control in it that just allows me to toggle that on and off really quickly. Now, let me show you this. Let's see what it took to implement that. In Windows 8, it was a pain because I had to build the settings flyout that you saw come out from the right side of the screen effectively as a custom control. In Windows 8.1, it's built right in. So in this app here, let's look at the Windows version. You'll notice there's a file here named about settings flyout.xaml and another one named preferences setting flyout.xaml. What I did is this. I right-clicked the project in Visual Studio, said add new item, and chose settings flyout as the item type. We should find it down here somewhere, right there. When I do that, Visual Studio adds a new XAML file to my project as well as a new XAML code behind file, and it basically gives me the UI in there for a settings flyout. I just then go in and add in, I customize that as needed, adding in a toggle switch control for example. So in Preferences Settings Flyout, if you look at that one, most of the XAML you see here was given to me by Visual Studio. Here you can see in the preview what it's going to look like. What I added in was this text block and this toggle switch control, and you can see that being done right down here. But what's also interesting is what happens in the code behind, because when the user toggles that toggle switch, I need to store that preference somewhere. What I chose to do is to write it into local settings. You see that happening right here. The moment the user flips that switch on or off, I write a value out to local settings. And then guess what? Each time this app starts up, before I load the recipe data, I reach into application data.local settings, find out whether the user has expressed a preference here, and if they have, what it is. And then I use that to decide whether to use local data or to use the HTTP client class in WinRT to go out in the network and get the data. So, settings contracts, simple matter of you responding to the user selecting the settings charm by handling commands requested events, you adding in the commands that you want the system to display in its settings menu, and then responding to the user selecting those commands by displaying settings flyouts. Windows 8, big pain to do that because there was no settings flyout class. Windows 8.1, they fixed it. It becomes now almost trivial to build and display these settings flyout controls. Last thing I want to mention in terms of contracts has to do with device contracts. Now, these aren't talked about a lot. Some people don't know they exist. But you may have noticed on a Windows 8 device that when you slide out that charms bar, there is a charm called devices. Now, there are actually a lot of things that can be done through that device's charm. A lot of things Microsoft built into it. For example, Windows 8 supports something called Play To. You can basically stream media content to a DLNA device. Microsoft exposes that through the device's charm. But the number one reason the developers care about the device's charm is because this is how a user prints from a Windows Store app. Okay? I want to show you how to print from a Windows Store app. Not a lot of documentation on this. What documentation there is pretty bad. I want to show you the basics. If you want to support printing in a Windows Store app, the first thing you need to do, probably when the app starts up, is create a print document object as I'm doing here. Then you need to read its document source property, and you need to store that away in a variable or field somewhere where you can access it later. For reasons that I won't go into, you cannot reliably read this property later on. So you need to grab the value of the property and store it away now so you can access it later on. Then, at a minimum, you need to wire up handlers for 3 events that fire when the user initiates a print job. The first is the paginate event. The second is the get preview page event. The third is the add pages event. Let me tell you what really happens here. When the user initiates a print job, your app is running, the user slides out the charms bar, taps the device's charm, sees a list of all the printers they can print to, they tap a printer. Right now that print job is beginning. The very first thing that happens is Windows fires a paginate event from the print document object. It is asking you, how many pages will this print document comprise? Now, one thing Windows does automatically, it displays a nice little print preview. And it wants to know right now, how many pages would this print job comprise so it can show that many pages in the print preview window. So you don't have to do any real work here. You just need to figure out, okay, how many pages is it? You call a method named setPreviewPageCount to communicate that to the system. Right after that event fires, you'll see Windows fire a getPreviewPage event. It's saying then, give me the XAML for page 1 so that I, Windows, can show it in the print preview window. Guess what? If the user uses the forward and back arrows in the print preview window to view page 2 and 3, etc., you'll see this event fire again once per page. Each time Windows is saying, give me the XAML that I can use to display a preview of this in the print preview window. Finally, if the user elects to follow through with the print job, if they actually click the print button after all this, then Windows will fire an add pages event. And what you're supposed to do here is call a method named add page once for each page that you want to send to the printer. And at the end, you call a method called add pages complete to tell Windows that you will not be spitting out any more pages in that print job. Now, we are almost out of time, so let me just go right on to here and then show you a quick demo. One thing that's important to know, remember, paginate is the first of the events that fire when the user elects to do a print or print preview. Your job in the paginate event is to tell the system how many pages this job will comprise, but oftentimes you can't determine that unless you know more about the printed page itself. Is the user going to print in portrait mode or landscape mode? What is the printable page area? Do you guys use A4 paper here like they do in Europe? And you know, in A4, a lot of Americans don't even know what A4 is. We tend to use the letter size, 8.5 by 11. You need to know things like that before you can compute oftentimes how many pages it will comprise. Well, it turns out that when Windows fires the paginate event, it passes you a paginate event args here that tells you a lot of information about the printed page. You can find out, for example, whether the user has currently selected the portrait or landscape orientation. You can find out what the width and height of the page is in pixels, and through this imageable rect, what the printable area of the page is in pixels. So basically, Windows at this point is giving you all the information you need to determine how many pages this print job might comprise. Now, let me close out with one example. I only have one example of apps that print, but it's something that can help you if you ever need to know how to do this, because there just aren't many examples out there. It is that application I showed you earlier that displays the Gettysburg Address. So let's go back to that real quickly. That one is called Contracts Demo, attached to this PC, this laptop. Oh, that's the wrong one. Wrong project. Let's try that again. Okay, there we go. I don't have a printer attached, but I can print to OneNote, so I'm going to slide the charms bar out, select Devices, Print, and I'll send to OneNote, since I don't have a physical printer attached. This is the print preview window where Windows is showing me what this print document is going to look like. Now, I've actually provided the XAML that Windows used to render this. It's responsive. If I change this to landscape orientation, you'll see what it's going to look like if we turn the page up that way. I've structured my XAML, by the way, so that it flows. I don't have to actually do any changes to the page programmatically. But then if I select print, then the print job will actually go out to the printer. In this case, it should show up in OneNote. So we'll just do an OK here, and OneNote is showing me what this thing would have looked like if it was printed. So pretty good facsimile there. So we're basically out of time, so I won't go through all this, but I will show you, if this is something that interests you and you want to find out more about how to do it. Let me find the requisite event handlers right here for printing. Right here, you see me doing what I showed you in the slides. I knew up a print document object, cache a reference of this property, and then wire up handlers for these events right here. In this case, it's a simple one-page document. So when the paginate event is fired, I just tell Windows it's just a one-page document, no more, no less. If I set a breakpoint in the code, I would then see this event fire where Windows says, okay, give me the XAML for page 1. Since it's a one-page document, this event should not fire again unless the print job is repeated. So I provide here to Windows the XAML, which I'm storing a reference to in a private field describing what I want it to print. Then, if the user actually elects to follow through and print, they add pages event fires, I add the page to the print job, tell Windows that there's nothing else to add, and that's basically it. So that is the basic approach that we take to printing from Windows. Now, remember, if you want these samples and a whole lot more, again, these are the samples that we use to teach Microsoft developers how to write Windows Store apps. Go to this OneDrive URL at your convenience, fairly large zip file. Feel free to share the code with colleagues, to use it for learning yourself or whatever. That's why I write this stuff. Thank you very much. I hope you had a great day at the conference. And if you're here any other days this week, come by our booth right outside this room and say hi to us. And drive safely going home, okay? Thanks.
Thank you, Jeff. I did like to thank all of you for participating in GIDS.net today. We look forward to your feedback. Tag your tweets and post with #GIDS.